I'm sure by now you know that Flutter is a hybrid framework that allows you to make mobile applications across several different platforms. But did you know that you can also make your own video games with it? That's right. With the help of the Flame engine, you can make your own 2D games with Flutter and Flame. And today I'm going to show you how to do just that on another episode of Trade Codes. So before we get started with this video, I wanted to give a special shout out to two YouTube channels that I watched to get some more understanding on how to use the Flame engine with Flutter. And those two channels are Dev Cage and Craig Oda. So I'll be sure to drop their YouTubes in the description below. Be sure to show them some love, leave them some comments, and check out some of their videos on their explanations on how to use the Flame engine with Flutter. So the Flame engine is a 2D game engine that is made on top of Flutter. All right, and it essentially provides you with a bunch of out-of-the-box components that you would need in order to make your own 2D video games. It comes with a game loop, sprites, animations, components, collision detection, audio, all the things that you can imagine for a game like Mario Brothers when it was in the 2D scrolling format. It provides everything for you. And like I said, it's built on top of Flutter, so it works very well with Flutter already, very modular, and you can actually put your games inside Flutter components. So it makes it very easy to use with apps that you've already created. So without further ado, let's go ahead and jump into the code. So first thing that we need to do is we need to head over to pub.dev as always and download the packages. We're dealing with two packages today specifically, and the first one is Flame, obviously version 1.4.0, and then we also need another package called Flame Audio, version 1.3.2. And Flame is what we use to make the video game. Flame Audio is kind of a package that's built into it, but you need to download it as well in order to play audio in your game. So I have this empty project right now, and we're going to be making a video game called Gift Grab. The idea of the game is Santa is going to be trying to grab gifts, and he has to dodge the ice blocks in order to build his score before time runs out. All right, very simple 2D game. So we have this project called Gift Grab. The packages are in pubspec.yaml right now, and we have an empty main.dart file, okay? So now we're ready to go ahead and start adding the components to make this game come to life. So something to keep in mind is we obviously need assets for this game, and those assets come in two forms, audio and images. So make sure that you have the directory set up this way. You want to have your assets folder and then break it down into two different directories, images and auto. And in these directories, we just have the background that we're going to be using, the sprite images for the ice blocks, the GIF, and then we have the images that we're going to be using for Santa as well while he's in motion and while he's standing still or frozen. We also have the audio that we're going to be using, which is going to be this freeze sound when Santa actually comes into contact with an ice block. And then we also have an item grab sound when Santa picks up a gift. So in your pubspec.yaml, you'll also want to specify it down here in the assets section that you have these audio and images directories that you want to have access to. Okay, so first things first, we need to create our actual game component. So what we'll do is we'll come into this lib directory, create a new folder, call it games, and then create a gift grab game.dart file. Okay. So we're just going to create our game, gift grab game extends flame game, okay? And then we need to make sure we have our proper import, cool. And then we'll need to override the onload method of the flame game. Future void, onload, async, cool. All right, so this is the very bare minimum of the game widget, and this is where everything is going to come from essentially. All our sprites and components we're going to be putting into this gift grab game. Keep in mind you can make multiple games, so if I wanted to have a gift grab game and then go to another game like a space shooter, I would create another space shooter game on to go on top of that, right? So this is how you would create the bare minimum for the game. In order to run it, we're going to, in our run app, we're going to take out this material app and instead pass in a game widget, and then we're going to specify the game, which is game gift grab game. Okay, make sure we import what we need. Cool. Now let's go ahead and run this and see what we get. So we should see a blank black screen, okay? Because right now there's nothing to the game. It's literally just the bare minimum. So it should be just a black screen that pops up. Okay, so our game is loaded as we expected, just a blank black screen. Okay, so now we're ready to start adding the components to the actual game. Next thing that we can do is go ahead and add a background to the app. So the background is going to be essentially a sprite component as well. So I'm going to create a constants directory, and this is where I'll have this globals file, globals.dart, and in here I'm just going to keep just a list of strings that are going to represent the paths to the images and the audio that we'll be using. So build this constructor real quick, and this syntax simply just means that we don't want to instantiate this class. We only want to use the properties that are in it. All right, so we're basically saying that we want the constructor to be private. So come down here, create a string variable, static const string background sprite, and it's going to equal our background sprite.jpg, just to make it easier. That way we don't have to misspell anything while we're actually coding, or if we accidentally do misspell something. All right, so we got that. Now we want to create a components directory, and this is where we're going to create the background component. Background component .dart. Okay, so the background component is going to extend a sprite component, and the sprite components are essentially, it can be the background, it can be the character in the game, it can be projectiles that are coming from the player, it can be items you pick up, anything like that is essentially a sprite. So it's going to extend sprite component, and then we need to add a mix-in called hasGameRef, which is going to give us a reference to the game that we're dealing with. That way, if we want to use any of the properties that are on the game class, we can use it within our components and things like that. So we'll say hasGameRef, and it is going to be of type GIF grab game. Okay. So same thing as in our game, we have this onload. Background component is going to do the exact same thing. All right, and we need to specify the sprite. So the sprite of this class is going to be, we need to use our game ref, and then we need to call load sprite, and we're going to load the path. Let me import this globals real quick. We're going to specify that background sprite path. I need to await this because it's an asynchronous method, and then specify the size, which is going to be GameRef.size. Okay, so we have our background component. Now the last thing that we need to do is we need to actually add it to our game. So we'll just call add, and then pass in that background component object. Okay, so if we refresh this, we should now have the background, as you can see, for our game. Next thing we need to do is, obviously we need to add Santa to the game. So we're going to create a Santa component similar to the background component. So I'll come into components, create a new file called SantaComponent.dart, and I'm just going to copy the background component logic into here, rename this to Santa component, and has similar logic, but we need to add a new path in the globals directory to specify the sprite for Santa. So since this is going to be Santa, while this is the first Santa we're using, we're going to be using this Santa idle PNG, just means that he's standing still. So we'll call it Santa idle sprite equals Santa idle.png. All right, then we'll change this to Santa idle sprite. Cool. So now we have the sprite. We need to specify the position, and the position, we're going to put him in the center of the screen right now. We're going to call GameRef.size divided by 2. This is going to put him smack dab in the middle of the screen. We also need to specify the height. So we can do that up here. Final double sprite height, and we'll set it to 200. The reason I'm doing this is because you can change the height of the sprite that you're using. It can be 300, it can be 5, whatever it is, but I like to keep it as a global variable. That way I don't have to keep up with what the size of the sprite is while I'm developing the app. So we need to specify the height of this sprite, and it's going to be sprite height, and then the width, it's going to be sprite height times 1.4.2. The reason I'm doing that is because this PNG is not evenly distributed around Santa. It's a little bit wider. There's some empty space on the side. So to make sure that it keeps its proportions proper, I'm going to multiply the sprite height by 1.42, but you'll see what that looks like here in a second. And then finally, we need to add the anchor. The anchor is just specifying where the center of this sprite is going to be at. So we're going to say anchor.center. Now there's other options like bottom left, bottom right, or whatever, but we want the center of this anchor, the center of the sprite, to be smack dab in the center. Okay, so we have our Santa component. Similar to the background component, we need to come to the game and then add the Santa component. All right, do our import. All right, now if we refresh it, we have our Santa component, just like that. Now, in order to take control of the movements in the game, we're going to have to add a joystick to the game. So a joystick is essentially on a joystick on a video game, right? So I'm going to create a inputs directory because it's technically an input, and I'm going to call it joystick.dart. And within here, I'm going to create a joystick component. Let me do this import, make sure I have it. Did I spell it wrong? There we go. All right, call it joystick. And we're just going to create the joystick component here. And now we're just going to configure it essentially to what we want. So first we need to specify the knob, which is going to be a circle component. And the radius, we're going to have it at 30. The knob is going to be the part that we actually move in the joystick. So we'll keep that radius 30. And then the paint is going to be, it's essentially the color, but we had to pass in a basic palette type. We'll call it red with alpha 200 and then paint, all right? So we have the knob specified. We also need to have the background, all right? That's going to be a circle component as well, but this time the radius is going to be 100, and this is going to be the outer part of the joystick. So the knob is the inner part, background is going to be the outer part. So it's going to be a little bit bigger, and it's going to be a little bit lighter, so we'll put 100. And then we need to specify the margin, which I believe is, yes, just edge insets only. We're going to put left 40 and bottom 40. So this is going to put the joystick right in the bottom left corner of the screen, okay? So now that we have our joystick, whoops, I don't need the semicolon there. Similar to everything else we've been doing, we need to come to the game class, add our joystick, just like this. Oops, let me make sure I import it, okay? Oh, I forgot. When we implement the joystick, we have to add a mix into our game class called has draggables. That way it can detect when we're using dragging features in the app. So we'll say has draggables, and we'll refresh this. And now we have our joystick, okay? So with the joystick added, we need to go ahead and add the movement to Santa. So we need to configure our Santa component, okay? So now that we're adding movement, it's to specify that it's moving, we're going to be altering between different sprites. So there's a sprite when Santa's standing still. There's going to be a sprite when Santa's moving left, when he's moving right, and also when he's frozen, but we'll get to that in a little bit. For now, let's focus on the two other positions that he can be in. So we're going to create an enum called movement state, and we'll have 3 states right now: idle, slide left, slide right, okay? And we're going to change our sprite component to sprite group component, and it's going to be based off that movement state, okay? Oops. So we need to add a few more properties. We need to add the speed of Santa, right? And that's going to be a double. And we'll use that in our equation where we're determining how fast he's moving a little bit later. So we'll call this speed, and we'll have him going at 500. Then we need to also specify 4 late variables that are going to be the boundaries of how far Santa can go on the screen. So we'll call these right bound, left bound, up bound, and down bound. Then we need to go ahead and create a constructor for, we need a constructor for Santa, because now that we have the joystick, we need to be passing in that joystick to Santa. That way, within this component, we know where the joystick is at, what data it has, where it's positioned, and all that. So we'll create a constructor, and we'll say required this.joystick, and then we'll create a property for the joystick, okay? Joystick component. So if we come down here, we have our sprite. Now that we have multiple sprites we're going to be using, instead of having 1 sprite, we're going to be making 3. So this sprite will now become its own sprite. We'll call it Santa idle. And then we need one for Santa left slide and Santa right slide. So we need to go into our globals and add these new paths for our different states that he can be in. So Santa left sprite is going to be, let's see, Santa slide left, all right? And then same thing for the right, but it's going to be Santa slide right, okay? Back to our Santa component. Let me close some of these out. Okay, so we have our 3 sprites. Now we need to specify the sprites property on the Santa component. So what we're going to be doing is we're going to essentially map these sprites to whatever movement Santa is on. So for movement state dot idle, it's going to take the Santa idle sprite. Movement state dot slide left is going to take Santa left slide, and movement state dot slide right is going to take Santa right slide. All right, so this is just saying that whenever he changes states, he's going to be taking on that new sprite, okay? Then we need to create the bounds for what we're allowing Santa to go for. So the right bound is essentially just going to be how far he can go right. And we're going to add a little bit of padding though, because we don't want him to go out of bounds. We need to consider the dimensions of the sprite component itself. So we'll do GameRef.size x, since x is going to be a left or right, minus 45, and the left bound is going to be the same thing, but it's going to be 45 because we're starting at 0 plus 45. Right bound is the size of the screen minus 45. Then the up bound is going to be 0 plus 55. We're going to add a little bit of padding from the top, so we'll make that 55. And then the down bound is going to be GameRef.size Y minus 85, just because Santa's kind of tall, so we want to add some extra padding from the bottom. All right, so we have our bound set, good. Then we also need to make sure that we specify the current, and current is a property that is on the sprite group component that specifies what state he's currently in. So current is going to equal movement state.idle. Next, we need to add the update function to our sprite component. It's a method that we need to override, update. And what this function does is it's essentially a game loop for the game. So any type of updates to the sprite that we want to add, we would add within this update method, okay? So what we're going to do in here is we're going to check and see, has he went out of bounds, has the joystick went idle and whatnot, and then after all that's checked, then we're going to update the position of Santa. And just to remind you, this function is called repeatedly because it's on a loop, okay? So the first thing we need to do is check if the joystick.direction equals joystick.direction.idle, and if it is, current is going to equal movement state.idle, and we'll just return. We don't want to do anything else. If it's not idle, which means it's currently moving, then we need to check and make sure that he's not out of bounds, okay? So if X, which is the current position of the component, if X is greater than or equal to right bound, which means he's going too far to the right, we want to set X to X minus 1. That's going to push him back 1 pixel on the screen. So if he tries to go out, we'll just stop and he'll keep looping just back and forth. And you won't even really see it because it's so insignificant, but that'll make sure that he stays within the bounds, okay? Same thing if he goes to the left bound, but this time we'll add 1. Then we're going to check the Y. If Y is greater than or equal to down bound, then we're going to bring him up or bring him back 1 pixel. So it'll be Y minus 1. And then same thing for the up bound. If he is less than or equal to up bound, then we'll need to add 1. Cool. Then we need to check and see which direction Santa is currently moving, okay? So we'll create a variable called moving left, and the way we check that is by the joystick's relative data at position 0. Now, if that is less than 0, that means he's moving left, okay? So if moving left, we want to update the current to equal movement state.slide left. Otherwise, he's moving right, or we can assume that, and we'll set it equal to movement state.slide right. Cool. And then finally, we just want to update the position. After you get through all that, the position is going to equal, after all that, we then want to update the position. We're just going to call it position.add. It's going to be joystick.relative data, multiply it by the speed, multiplied by dt, which is the value that is passed in from the update function. All right, cool. So I know there was a lot of logic, but we had to make sure that we have everything in here in order to make sure that Santa's moving properly. All right, last thing that we need to do is within this Santa component, we need to pass in that joystick that we specified in the constructor. So we'll say joystick. All right, cool. So now if I refresh this, oops, something's not right. Let's see, slide left, slide right. Oh, the sprites didn't have the right path. Slide Santa left sprite and right sprite. Now if I refresh this, there we go. When we go to the left, Santa's sliding left. When we go to the right, Santa's sliding right. So now we added movement to Santa. So real quick, I actually made a little bit of misjudgment in the logic for the bounds. So 2 things. First thing is, we don't want to decrement or increment the values based on their current position. Otherwise, that would just let Santa fly free off the screen, as you can see. And that wasn't the correct logic, okay? So what we want to do instead is we want to decrement the point based on the bound that he's currently at, okay? So we'll do right bound minus 1 when he goes farther than the right bound. Also, this should be less than. And then we want to do up bound plus 1. Down bound minus 1. Okay, so if I refresh this, it should have the proper bounds applied. So if he goes up, all right, can't go off the screen up, can't go down, can't go right, and he can't go left. All right, So that's fixed. Now that we have Santa in the game, we want to go ahead and add the gift sprite because that is the whole purpose of the game, Santa collecting the gifts. So let me close some of these out. Actually, we'll keep this one open because we're going to be copy and pasting this logic. So we'll come to components. Actually, let me go ahead and go to globals and add that gift sprite first. Create gift sprite, and that is going to be gift sprite. I believe that's the name of it. Yeah. Oh, PNG. Gotta make sure that we have the right file extension. Cool. So now we'll come into components, create GIF component .dart. We're gonna copy and paste this logic here. Whoops, I don't know what I just did. Copy and paste. All right, change the name from background component to GIF component. And the sprite that we're going to be loading is the GIF sprite. Let me go ahead and add that sprite height up here. Double sprite height. Now this one is more proportional off rip. The GIF, it doesn't come with anything wacky, so we can just go ahead and set the height and width. You can do it like this actually. Look at that. All right, so we have the height and width to be the sprite height. Right now we're going to have the position be in the center of the screen, so we'll call gameref.size divided by 2, and then as said previously, the anchor is going to be anchor.center. Cool, so we have our GIF component just like that. Then we need to come into the GIF, grab game again, and go ahead and add the GIF. So we'll just add GIF component. All right, so if I refresh this, you now see that we have our GIF component. Keep in mind that you see that Santa is under the GIF. This isn't anything to really be alarmed about, but just know that as you add layers, they're going to be presented as layers in the game as well. So if I wanted Santa to be over the GIF, I would need to add Santa after the GIF component. But like I said, we have our GIF component in the game now. So now that we got Santa and our GIF on the screen, we now need to add a collision that will take place between Santa and the GIF. And the collision is going to let us know that these two components have now interacted with each other. So we need to first go into our globals, and now we're going to add a path to some audio because when Santa collects the GIF, we want to play that item sound. So we'll call string, call it item grab sound, okay? And that's going to be item grab sound dot wave, okay? We have that. Then within our game, when Santa collects a GIF, we want to update his score. So we need to create a variable that's going to keep record of his score. So within the game, we'll have an object called int score, and it's going to start at 0, okay? Also need to add has collision detection mixin in order to allow these two components to interact with each other and know when one component has hit the other, okay? Then we also need to preload our audio. Now you don't have to do this, but it's recommended just because if you try to play sounds in the game that haven't been loaded yet, there might be a delay and you wouldn't want Santa to pick up a GIF and then you hear the sound 2 seconds later. So instead of doing that, we can do flame audio, let me import that, audio cache, load all, and then we'll just pass in our globals and item grab sound. Then we need to come into our GIF component and modify this in order to allow the game. Essentially what we want to do is when Santa picks up a GIF, we want to remove that GIF, increase his score, and then move that GIF, or create a new GIF that's going to be placed somewhere randomly on the screen, okay? First thing we should do is add the collision callbacks mix in, collision callback, I think. Here we go, collision callbacks. And this is going to give us the method that we need to handle the collision. Then we'll need to add a random object. We're going to import that. And this is going to allow us to create a random position. Then we're going to update the position to be get random position. And this is going to be a method that we're going to create that's going to return a random vector object. And the vector is based off of X and Y coordinates. So we're going to randomly create an X, randomly create a Y, return that position. And now whenever the new GIF is added, it's going to take on a random position. So if we come down here, we'll create vector 2, get random position, and we'll say double X equals random dot next int, and it's going to be gameref.size.x dot to double. I believe that should work. Let me see what the error is. Oh, okay, it's a double, so we had to cast it to an int. Okay, so what we're doing right here is, based on the screen size of the x-axis, we're going to create a random value between 0 and the far out bounds, or as far as the x can go, okay? We'll do the same thing for the y, okay? Then we're going to return a vector2 object and specify those x and y coordinates. All right, so now we have our get random position method. Then we need to add our collision method, which is a method that we override. Void on collision, pass in a set of vector2 objects called intersection points, and then a position component called other. And then we'll do super on collision, passing these values. All right, so within this method, this is going to give us the intersection points, like a set of intersection points that happen between the two components, as well as whatever component it just came in contact with. Right now, it just says position component, but we can do a check in here that's going to say, all right, what did this component just collide with? If other is Santa component, then that means that this give component just ran into the Santa component. And then we would need to perform the logic necessary for Santa showing that he just actually collected the gift. So first thing we want to do is we want to play that sound that of Santa picking up the gift. Okay, so we're going to flame audio play globals dot item grab sound. Okay, then what we want to do is we want to remove this component, which is the current gift component that just got collided, from the game. So we'll call remove parent. Then we want to update the score of the game by 1 point because he just collected one gift. And now that that component's been removed, we want to add a whole new gift component to the screen. And it's going to be placed at a random position because we specified it here in the onload method of this component itself. Okay, so if we, then we also need to add a circle hitbox to this component. I believe I need to import, actually I just misspelled it. Okay, all right. So we need to add a circle hitbox to the component that lets it know that this component, the circle hitbox applied to it is how we detect that it's collided with something. Without adding that circle hitbox, this component has no idea that it's interacting with other ones and it technically will go unseen among the Santa component, all right? And we need to do the same thing in the Santa component as well. So that's all we need to do for the give component. We need to come to the Santa component and apply a circle hitbox also. We'll just add it down here, all right? And we already has collision detection. So we should have everything we need in order to make this perform how it needs to. So let's go ahead and try this out. Cool, all right. So as you see, Santa picked up the gift. For some reason, the gift didn't pop up randomly though. Something's missing here. I know what it is. We need to do the game ref.add gift component because we need to add the gift component to the game. I'm not sure what add was doing, but if we do game ref.add gift component, now when Santa collides with the gift, it should pop up another one. There we go. So right now the game is pretty simple. Santa's grabbing the gifts and there's no obstacles, right? We need to add some type of challenge to the game. And the way we do that is we're going to add 2 ice blocks to the game, to the view, and Santa has to dodge those, but I'm getting ahead of myself a little bit. Right now, let's just add the ice component to the game. So we're gonna go into components. Now we're gonna create an ice component, all right? Let's go into global and add that ice sprite, change that, ice sprite, PNG, okay. And we're gonna copy this background component logic into the ice component, change the name to ice component, all right. Then we need to have 2 variables. We have the sprite height, as always, okay. Make that final. And then we're going to be putting 2 of them on the screen, kind of in diagonal positions. Like we know exactly where they're going to be at. We're going to put them in 2 different corners. So we're going to have a start position for this component that'll be specified on construction of the component. So we'll say ice component required this dot start position. All right. Now the sprite, we're going to pass the ice sprite position is going to be the start position, and we're going to have the width and height equal that sprite height, and then as earlier, anchor is going to be anchor.center. cool. We have our ice component just like that. Now we want to come over into our game and we want to go ahead and add our ice components. Now, since we know that we want them in two different corners of the screen, we're going to have one that's going to be about 200 in the x-axis, 200 in the y-axis, and then 200 above the down bound of the y-axis and 200 from the right bound of the x-axis, if that makes sense. So I'll show you what that's going to look like. So we'll add an ice component. First one start position is going to be 200, 200. Oops, that's a vector 2. We need to import this. Okay, and then the next one is going to be size.x minus 200 and size.y minus 200. Okay, so if I refresh this, we have our two ice blocks in the two corners of the screen. The ice components are on the screen, but they're not moving anywhere, so we need to add some movement to those. So we need to add a couple variables. We need a velocity, which is going to be a vector 2. We need speed, and we're going to make the ice cubes go a little bit slower than Santa because he's going at 500. We're going to have them going at 300 just since there's two of them. We're going to make it fair. Then we need to have the degree, and we're going to use that in our equation to know when these ice cubes are bouncing off the wall. So the premise is they're going to hit a boundary, bounce at an angle, and then go to another part of the screen. All right, so they'll be bouncing around the whole screen. They'll never leave the screen. They'll just be bouncing around throughout the whole game. So we'll do double degree equals, we need to import this math class. Then we need to come down and create the update method, override it I should say. And this is where we're going to update the position. We'll do position.add. It's going to be velocity that we specify up here times the speed times dt. So we're going to update the position to be velocity. Oops, I'm just going to copy and paste it. Times dt. That's a error on my part. The velocity is a vector 2. All right, cool. So we have that. Then we need to create a method called getSpawnAngle, and this is just going to determine what the angle is after an ice cube hits the wall. So double getSpawnAngle. We're going to get a random math.random next double. Then we'll get the spawn angle variable, and we're going to use this lerp double method and pass in these properties to get that random, and we'll need to import this from Dart UI. All right, and then we just return the spawn angle. So this method right here, I'm not 100% sure exactly the magic that works right here. I believe I saw it on Stack Overflow or somewhere, but it essentially is going to, says linearly interpolate between two numbers A and B by an extrapolation factor T. So with this magic right here, we're able to get our spawn angle. Then up here in the onload method, we're going to get that, we're going to create a spawn angle variable from this getSpawnAngle method, and then we're going to perform some math to get the X and Y. So we'll say final double X Vx equals math.cosine spawn angle times degree times speed. We'll do the same thing for Y, except we're not going to use cosine, we're going to use sine for this one. Oops, I didn't mean to restart that. And then we're going to set that velocity equal to a vector 2 object of those values. Okay, so just know that, I know this is like a lot of math and can be kind of confusing. I had to look up some of this obviously, but this is basically just getting the new angles that we need whenever it hits the wall and bounces to a new area. If we refresh this, oh, okay, that's right. So yeah, it's acting how it should. Right now, we have, as you can see, two ice cubes, but there's no boundaries on them. So they're just going off the screen. As you can see, we start with two ice cubes and then they just go out of bounds. Okay, so we're going to fix that. So we have our ice components on the screen, but as you can see, they're currently going out of bounds. So we can fix that really quick by adding some collisions. So as previously stated, we need to add the collision callbacks mix in. Then what we need to do is we need to add a circle hitbox to this ice component to specify that it is a component that it needs to be keeping record of different collisions in the app. So add circle hitbox, okay? Then we need to come down here and we can just copy this from Santa, actually. Does Santa have any collisions? Maybe not Santa. Okay, the GIF had the collisions. Okay, on collision, we'll put this in our ice component. Okay, so instead of checking for a Santa component in the ice component, we're going to be checking for a screen hitbox. And while we're at it, we'll go ahead and add that to the GIF game. We'll just add screen hitbox. So the screen hitbox is a component that detects any collisions that happen on the bounds of the viewport. So this is perfect for making sure that the ice cubes stay within their bounds on the screen. So why am I getting this error? Oh, okay. So we'll take this out, and within the check for if it's a screen hitbox, we're going to get a vector2 object called collision. Let's just call it collision point, and it's going to equal the intersection points dot first. Okay. Now remember, the intersection points are a set of vector 2s. So it's a set of vector 2s, so we just want the first one, okay? So in here, we need to see if collision point dot x equals 0, which means that it has hit a collision point to the left, then we need to update the velocity. We need to negate the velocity on the x-axis, essentially. Velocity.x and negate that. So this is pretty much saying, if you get to the left, do the opposite, go back to the right. Okay, or if you go up, do the opposite and go back down. The Santa one was a little bit different. We're creating a hitbox for this one because the Santa one we're actually controlling. The ice cubes were not. They're on their own movement. So we need to have a screen hitbox to kind of prevent them from going out of bounds on their own. So this velocity y equals velocity dot y. And we need to do these for all cases. So the x's, we're going to negate the x's. So the next scenario for the x to be out of bounds would be the game ref dot x. Okay, that means it went to the right, negate that, come to the left. And then we'll do the same thing for the y's. If it hits 0, that means it's at the top. We're going to, instead of negating the x, we're going to negate the y, and then do the same thing for when it's at 0. So it should be all that we need to do. We added the screen hitbox to the game. We have our collision here. So let's see what this looks like. Perfect. So as you can see now, the ice cubes, they hit the corners, but they don't go out of bounds. So this is exactly what we wanted. The next step is when Santa comes into contact with one of the ice blocks, we want to temporarily freeze him for about 3 seconds to prevent him from going to grab the next gift. Okay, so as you guessed it, we're going to need to modify the collisions a little bit more. First thing we can do is come over to our globals, and we want to add another path to the freeze sound, because now when Santa runs into an ice block, we're going to play the freeze sound. And change this, cool. And then we have another sprite for when Santa is frozen. So we'll call it Santa frozen sprite. Santa frozen PNG. All right. Then we also need to go into our GIF grab game and preload that frozen sound, the freeze sound, I should say. Then we need to come into our Santa component again, and now we need to update our sprites. So now that there's a new state that Santa can be in, it's called frozen. So we'll add that to the movement state. Add that sprite here, which is going to be Santa frozen. All right. Make sure we map it in our sprites here. So when movement state is frozen, we're going to see Santa frozen. Then we can go ahead and add these variables as well. So we need a Boolean value that's going to represent if Santa is currently frozen. So we'll just call it frozen, default to false. And then we need a timer object, timer, that is going to be used to represent how long Santa is going to remain frozen, okay? So within our update method, if we come down here, so all the logic that we currently have, this is all based on Santa not being frozen. So we can just go ahead and put this within an if statement that says, if not frozen, what is that? If not frozen, perform all this logic. Otherwise, we need to check the timer. We need to update our timer and then check the timer and make sure that it's not finished, okay? So we'll call our timer here and call update and pass in DT, which comes from the update method. Then we need to do a check and see if the timer is finished. If timer finished, then we're going to call a method called unfreeze Santa, okay? and we'll go ahead and map that out here in a second. But we need to also add collisions within here. So we'll come back to this class just to copy and paste. We'll add a collision here. So this collision is going to detect when we run into an ice block, okay? Oops, I think we already have it. No, we don't have it in here. Oh, I gotta add it. Collision callbacks. Can't forget your mix-ins. Collision callbacks, okay? Come down here. So if other is an ice component, what we wanna do is we wanna simply call the opposite of this unfreeze Santa method. We're going to call a method called freeze Santa. So essentially what we're doing is when we run into an ice block, we want to call freeze Santa, perform all that logic. And then as the game is looping and updating, we're going to check the timer to see if the timer has ran out. If it has, which means it's finished, then we unfreeze Santa and he can keep playing. Okay. So now we need to go ahead and make our methods for unfreeze Santa and freeze Santa. So first thing that we do in unfreeze Santa, all we're going to do is set the frozen variable back to false, and then current is going to be movement state dot idle, which is essentially all we're doing. When you unfreeze him, he's no longer frozen and he's back to his normal position. For our freeze Santa method, we're going to be doing a little bit more, but first we need to check and make sure that he's not already frozen, because we don't want to call frozen multiple times. The thing with the collisions, they run rapidly, right? So this freeze Santa method could be called 100 times within 1 second. We don't want to do that. So we're going to check and make sure that he's not already frozen. So if not frozen, then we want to play the sound first of the little frozen sound that we have. Globals.freeze sound. Then we want to set the frozen property to true. Then we want to set the current state of Santa, his movement state, to frozen. And then we want to start the timer. And that's all we need to do, okay? So if I refresh this, let's see how this looks. All right, so when he hits an ice block, he goes down on his stomach. That means he's frozen. He can keep playing, but if he runs to an ice block again, then he's frozen, okay? So that's working how it needs to. Now, the game is essentially complete as far as the functionality, but we need to let the user know what the score is currently, as well as how much time they have left, because we don't want the game to go on forever. So I'm thinking maybe 30-second rounds, and then we also need to be able to know how many gifts Santa has collected so far. All this is going to happen in the gift grab game class. So we need to create a few variables. We need to create a timer in this class, and we'll configure that in a second. Let's do our import. We need a variable for the remaining time. We're going to do 30 seconds by default. Then we need a text component to represent the score and a text component to represent the time. So within our onload, we're going to configure the timer. It's going to increment every second. We want it to repeat. That means it's going to keep every tick. It's going to repeat. If repeat is false, it only tick one time, but we want to count down. So we're going to have repeat equals true. Then we want to specify what happens on every tick. So within every tick, we want to see if remaining time equals 0. Then what we want to do is pause the game. So we'll call a method called pause engine. That means game is done, let's stop. But if remaining time is not 0 yet, then all we're going to do is decrement the remaining time value, minus equals 1, okay? Then we can go ahead and hit timer.start. That way time starts as soon as the game loads up. Within here, we can set our score and time variables as well. So score text is going to equal a text component. The text is going to be score. We want the position of this text component to be in the top left corner. So we're going to say vector2 4040, and we want its anchor where the 4040 position is represented is going to be the top left. So instead of center this time, it's going to be top left. And then we want to style it just a little bit. So we'll call text renderer text style. Then we want to style it a little bit. So we'll call text renderer text paint, I believe. Yeah, text paint style, text style, color, basic palette. We need to import these. Basic palette, white. And I have a typo here. It should be text renderer. And we can make this a const variable. Oops, maybe we can't. And then font size is going to be 50. Okay. Now since this is a component, we're going to add it to our UI, just like everything else. We're going to copy and paste it and do that the same exact thing for the time text, except this is going to say remaining time, or remaining time seconds. And actually we'll put time right here, okay? Now this isn't going to be 4040, this is going to be size.x minus 40, and its anchor is going to be top right because it's going to be in the top right corner, okay? And then we'll add the time text. All right, and then last thing we need to do is we need to have another update method within this class. This one didn't have one already. And we're going to need that because we need to update our timer. So we need to update our timer as well as update the score and the time in the app. So we'll call update, pass in DT, and then score text.text. As this is being updated, we're going to update the score to be score game ref.score. It should work. Oh, I'm sorry. We don't need a game ref because we're already in the game, and we don't need those brackets. Perfect. Okay. And then same thing for time text. It's going to be time, remaining time, left. We'll just say left. Actually, we'll say seconds. Oh, forgot to, whoops. Let me add the super call here. All right. So that should be everything we need to do to see the time and text on the screen. So let's try that out. All right. So as you can see here, we have our score on the top left, time on the top right. So if I pick up a GIF, all right, score is 1. These ice cubes are tricky. Got 12 seconds left. 2, 3, 4. Can I get this last one? Yeah, dang, couldn't get it. All right, so when time ran out, the engine was paused, so the game actually stopped. But we now have the UI for seeing the score and seeing the time. The game is now almost complete. Now what we need to do is add some finishing touches. We're going to add a home menu. We're going to add a game over screen to let the user know what their score was and if they want to play again, and then a reset method that's going to restart the score and the timer. So we can go ahead and add the reset method down here. We'll just call it reset, and we're basically just going to set the score back to 0 and set the remaining time back to 30. Okay, we have our reset method there. Then within the remaining time, this basically signifies that we need to display another screen, and we're going to display the game over screen here. So the game over screen is essentially going to be an overlay, and I'll explain a little bit more what that is in a little bit, but we can go ahead and call overlays.add, and we're going to add the ID of the screen that we'll be adding, and it'll be like a map. It'll be an ID mapping to a screen. For now, we'll call it game over menu.id. So ignore the red squiggly lines now. We're going to specify that in a second. So that's all we need to do in the game. Now we need to come into our lib directory and create a screens directory. So the screens, first we're going to have game over menu.dart. So we have our game over menu.dart, and this is going to be, the good thing about the screens is they're just stateless widgets. All right. So this is where Flutter just fits in perfectly. So game over menu extends stateless widget. Actually, let's do this. Stateless widget, game over menu. No, stateless widget. I'm tripping. Game over menu. Then we need to specify that ID. Static const string ID equals game over menu. And we'll be using this to let our overlay mapper know which one we want to go to. Then we need to create a reference to the game. GIF grab game is going to be game ref. So when we pass it into the game over menu, we're going to say require this.game ref. And for the sake of time, I'm going to copy and paste just the UI that I made for this game over menu. Okay. We need to import its constants. So essentially what this is, it's a scaffold with a container that has the background sprite. There's a game over text that just says game over. Then we have the text that displays the actual score of the game. Then we have an elevated button right here that says play again. And what happens is when we hit play again, this overlay is removed. The game is reset from that reset method we created. and then we resume the engine because it was paused. So that's the game over menu right there. So we can go ahead and import this now. Cool. Now we need to add another screen called main menu.dart. This is another stateless widget, main menu, and I'm gonna copy and paste this main menu. Same thing as before. It's gonna have a background of our background, which is that snowy background sprite, a text that says gift grab, and then a button that says play. And what's gonna happen is we're going to push our widget of the actual game onto the stack and go to the page that plays the game. So we have the game over menu and main menu. Now we need to create this gameplay menu right here. Gameplay, and this is a stateless widget as well. Gameplay, incorporate that. I'm going to copy and paste the logic here. So essentially the gameplay widget is a stateless widget, and instead of putting the game widget in the main.dart file, we're instead putting it in this gameplay widget right here. And something to keep in mind is since we create a page for this, we want to create an instance of the game to pass into the game widget right here. Otherwise, if we did this, gift grab game, if we did this game will be recreated on every load and it will throw some errors, and we don't want that. So we're going to first, let's import this. Well, let me do this. Final gift grab game, and then hopefully, let me see, import game, import that. So within the logic right here, I need to create a gift grab game, call it gift grab game, and then import the gift grab game. And then we need to import the game over menu as well. So basically within the game widget, we already have that game as specified, but then we also have this parameter called overlay builder map. And what this does is it maps that ID that we specified in the game over menu to this game over menu widget. So now our game is essentially in this gameplay widget, and instead of being, let me go ahead and import this. Instead of being in the main.dart like this, we can instead just return a material app. Let's turn that debugger banner off, and then the body, home is going to be the main menu. Okay, so let's go ahead and see what this looks like when we refresh. All right, so we have our main menu, says give grab, play button, hit play. We're taken to the game. All right, so let's play a quick game. See if I can get to at least 12. Oof. Ooh, I'm not gonna get 12. I was frozen twice. I'm about to get frozen 3 times. That's bad, but I still got it. Let me see. I can get 12. Yeah, I can get 12. I can get 12. Easy. Man. All right, so the game ended. It says game over. Score is 10. Do you want to play again? If I hit play again, it's reset, and now I can play again. All right, that is how you make a 2D game in Flutter and Flame. If this video was helpful, please like, comment, subscribe. Let me know in the comments your thoughts about creating your own game, and be sure to leave any feedback on any game ideas that you might have, or anything that you would love me to discuss a little bit further in detail about how to make games with the Flame engine. Until next time, have a great day. Peace.